Hi everyone, good evening. Thanks to Phil and Nick and the team for inviting me back again. I did a talk about a year or two ago, I think, where we could still meet in person at the Birmingham City University, I think, on IoT. And it was great to actually be in a room with people. I'm hoping that's not far away. And thank you to everyone for coming on the call tonight, because I know you've probably spent most of your day on bloody Teams calls. Same as me, and so to spend your evening watching some more, really appreciate you coming along. I am going to do some slides. I'm hopefully going to romp through those quite quickly, because I want to show you a couple of things as well, a bit of a demo. One of the nice things about working in the IoT team is that we do get some quite nice toys, and I've had the latest toy has actually been delivered today. And I'm just going to try and put that up there. So if you recognize that, this is an Azure Percept kit. So this is our IoT edge-based technology for doing AI workloads through custom vision, and that's a microphone array as well. So that's one thing that to play with. I'm not going to be showing you that tonight, but I do have a Hololens as well. I'm going to be showing you this towards the end, because it's a really nice way to light up and sort of finish the digital twin story in terms of what we do with all that data. But what I will do now is go through the deck, and let me just get to Teams and share the screen there. And let's also share the computer audio, because I want to do devices audio setting. Okay, no problem. Doesn't matter that if I can't share that right now, because it just means that you won't get the narration from the HoloLens, but that's not too much of a problem at all. Okay, so let's go through the slides then. If you want to ask any questions at any point as I'm going through, Phil, you probably have to tell me if there's something coming up in the chat window, because I'm going to use the here. Yeah, thanks, mate. No, that's great. Yeah, okay. So tonight it's about Azure Digital Twins. I'm a senior technical specialist in what's called global partner services. We've had a couple of reorgs, so I won't bore you with the details of what that means. But Azure Digital Twins itself is one of the newer pieces of the story for us in the IoT division, and I'll show you how this comes into context a little bit later on. Standard marketing slide. I just want to show it because Sam, George and Satya always use it. We talk about these two things, which you'll hear about all the time, and digital twins is one of the pillars that we talk about as a piece of technology that really glues together the edge and the cloud and helps us to build solutions with customers and partners. And the reason that digital twins is becoming so important, and I've seen this firsthand now, is that when we started with IoT or machine to machine years and years ago, but let's use a more recent frame of reference and say in the last 5 or 6 years when Microsoft were releasing the IoT specific services such as IoT Hub, the conversations were all about remote monitoring. Get your devices connected to the cloud. And that was pretty much the story. And as things have started to get more complex, what the industry has been demanding is to say, this is not just about a set of devices where we've got some values and we can look at the values on a dashboard. The industry is demanding more. And digital twins is helping us to move towards this stage of what we're calling a connected ecosystem. And I've seen more examples of different partners, different companies talking about collaborating and working together because of digital twin, more so than I've ever seen, I think, with any other technology that we've had. And hopefully the reason for that will become clear as I go through the slides. So the definition of a digital twin from I suppose a non-technology perspective right now, and everyone is using the term digital twin. It is the really hot buzzword in the industry and has been probably for the last year or two. A digital twin is obviously a virtual representation of physical things in the real world, and those things could be people, they could be environments, they could be buildings, they could be machines. And the key thing is that we take information about that physical world and we construct a virtual version of it using a well understood terminology in the domain. And again, I'll explain more what that means. Then we take some data, some telemetry coming from sensors or other business systems and pull it together into one single place. And you could say, and my kind of first reaction to this was, okay, so what? It's a database with lots of stuff coming into it. People have already done that, and yes, they have. People have built digital twins based on RDBMS systems. A partner of mine have built something on SQL Server. The table schema is quite complex and it's quite rigid, and it's only really suitable for one domain. When you start to use a graph database underneath the covers, you get a huge amount more flexibility in terms of the domains that you can model because of the more complex relationships in other domains, as we'll start to see. So we've got all that information in one place. What happens when we've got all that information there? We can clearly do the things that we've always done with any other IoT solution. Okay, this is nothing really new, but it does open up some more interesting areas where suddenly, because all that information is together, it's much easier to do it when you've got it all inside a digital twin. And I'll give you some examples specifically of the visualization of how that all comes together and what we do with it. Analytics and simulation now, specifically with simulation, becomes a lot more realistic because all that information is again together in one place. You can run what if scenarios and pass data back in that feedback loop, as you can see there from the alerts, actions, and the feedback part. So taking a slightly more technology view now and thinking about what we do as Microsoft, Azure Digital Twins, as you may know, is a PaaS service. It's platform as a service. It essentially lives as a rather boring looking service within the Azure portal. There's not actually anything exciting built into it from a portal or visualization perspective. It's really about what you build around it. It is essentially a graph database with an API in front of it, with some extensions to allow you to raise events, process those events, and egress data. One of the most important aspects is this thing called the Digital Twins definition language that allows you to define how you represent your physical model in the real world. But I will talk about that in a minute. And these are typically the services that you would see around a digital twin. So a bit more of a detailed slide, and this sort of looks similar to the typical IoT slide that we always show, with the things on the left hand side, insights, and then actions on the other side. And you can see their digital twin here is the heart of the solution, because in order to get the value from it, you really do want as much data as possible coming into the digital twin. It might not necessarily be the system of record or the master for something, say like your asset management, and there are always debates going on as to what the right way to handle that is. If you see there on your business systems, your business applications, you're probably going to have some kind of asset management system, a building management system that have been in place for a long time. So pitching the digital twin is all about understanding the best way to get value from all the data that you're putting in, and working out which of your systems are going to be the master, how you're going to push into it, and how you're going to pull out of it. But you can recognize this as pretty much any other IoT solution, but with digital twin put in, probably as one of the legs of a lambda architecture. So if you've got, say, a hot path now using, say, Stream Analytics, etc., a cold path with Azure Data Lake, and a warmer path with, say, Cosmos or SQL, you can treat digital twins as one of the legs of that lambda architecture. It is another data store. You do need to think about where it fits best. It can handle hot path. It can handle the last known values, but it's not a historical data store for historical time series. And I'll come on to how we handle that particular use case later. So thinking about actually creating a digital twin solution, the real effort that is required to get value from it is in this modeling the digital twin, and that is understanding your physical domain. Now, this means that you really do need the input from the domain experts, from the business analysis people, from the process people, the asset management people, because you've got to pull all of that data together and model it in such a way that it's going to be representative and actually enable you to get some really good insights from it. It's only ever going to be as good as the quality of your model. You can put in all the telemetry data you want, but you're not really going to be putting yourself up that value chain if all you've got is some bare sensor readings and you're not tying that back into physical entities in the real world. So if you get that piece right, and add these data sources in with that telemetry, they could be making changes also to the structure of the twin itself. And I always use the analogy of a standard database. You will take time to design a schema. You get your tables right, you get your relationships right, and then you put data in. And Azure Digital Twin is no different. This modeling of the digital twin, which I'll show you using the DTDL, it's you defining your schema, or it's you defining your object model in an object-oriented programming language, and then instantiating those classes or entities, putting the data in there, and then connecting the insights that you're making back into your business systems. And then actually visualizing that in a meaningful way to an end user. Okay, so talking about modeling the digital twin itself, then we use this language called DTDL, Digital Twin Definition Language. This is currently at version 2, and it's based on JSON LD. If any of you have had a look at IoT plug and play, it will be familiar to you, because the language that we use for IoT plug and play, where devices advertise their capabilities in the same way that Windows 95 introduced plug and play for peripherals, for those of you who've been around long enough, DDTL is used for plug and play for those devices. So you can go to our Azure IoT device catalog, find a device, and it will say, here's my JSON LD schema of all my capabilities. You can import that into IoT Central, build the dashboard. Perfect. You've got much less configuration to do. DDTL for digital twins is a superset of that, and it's what we use to define all the elements in the physical environment. And I'll show you some of this. So again, I'm just going to romp through these slides and actually get into to show you some of this stuff. Now, one word that you will hear all the time is this topology, or ontology is used as well, which is a really collection of models in a specific domain, and I'll talk some more about that later. The reason this is so important, and this is one of the real, when I said so what about digital twins, I'm seeing now partners really coming to work together through the fact that they are talking a common language in a domain space. DDTL itself is based on the RDF principle, where you effectively, it's a way to describe a meta model. Anyone who's done any object oriented programming, this will make sense to, because you're kind of comparing entities, building entity attribute and value. So for example, I could say the sky has the color blue, where sky is the entity, color is the attribute, and then the value is blue. So it's kind of just that meta model, and we like to say that we're conforming with these standards, just to, I think, keep the academic world happy. This is what it looks like. Not too much of a surprise there, I'm sure. They're all based around this high level concept called an interface, and then we add in our properties and telemetry stuff. Just a quick word on the difference between property and telemetry in digital twins, because it can be quite confusing. Property is backed with the data store in digital twin. Telemetry is essentially a pass-through event, if you like, that simulates something coming from a device, a piece of telemetry. Properties are generally used if you want to hold that state, so you're in the last known state in the digital twin itself. So here are the elements that make up DTDL. We support interface inheritance, which is very useful when you're starting with an ontology. I've got a partner who started off with the real estate core ontology for smart buildings, and they've extended that to help them do the 3D visualization, which again I'm going to come on to. Let's see how we're doing for time. That's cool. Okay. So data sources. So we've built our model inside digital twin based on the model files that I'm going to show you. I want to show you a few architecture patterns now, because this is really going to help to put digital twin into context of a wider solution, because of course, as with any other PaaS component, digital twin is no use on its own. It only has value when you surround it with other PaaS components. If we're getting ingestion from IoT Hub, what we typically do is use an Azure function to push into the REST API. At the moment, the ingest mechanism for Azure Digital Twin is a REST API, so it's compatible with pretty much everything. We are looking at, as a general point, the more popular solution PaaS components that you would expect to see in a digital twin solution. We are investigating closer integration and easier integration with those services. I'm sure that won't come as a surprise, but today we get data in from Azure IoT Hub. For some reason, the examples always show using an event grid rather than a function triggered off IoT Hub itself, but that seems to be a matter of personal taste for the people who put the examples together. And what the Azure function is doing here is translating that IoT device ID into the twin ID. Now, how you design your sort of your linkage of your common IDs across the system is obviously one of the critical things here. And if the device ID in IoT Hub isn't going to be the ID in the digital twin, you obviously need a lookup to do that. And below, if you've got a pattern, if any of you used IoT Edge or a gateway, you'll know that there are different patterns, one of which is identity translation, where the IoT device on the left-hand side there doesn't actually have an IoT Hub identity. So you can perhaps use one of the message properties that's been decorated by the gateway to then push that into digital twin. So just another way to do that. Logic apps are often appear in the examples and real world customer solutions we see as well. Very useful for linking in with the business systems, perhaps the asset management systems, where you need to synchronize a new asset appearing. You need to create a new twin instance in digital twin. You can do that through Azure Logic Apps quite easily. And again, an event hub of Egress with an Azure function, very, very similar pattern to the IoT Hub one that I showed you before. Okay, so what happens when we've got our data flowing in? What are we then going to do with that, and how do we integrate with it? So Azure Digital Twins allows you to set up an egress route to an event grid or an event hub. So that event gets raised by digital twin when something changes. You can then pick that up through an Azure function trigger, send that on to another service, perhaps do some processing, and maybe even send something back into digital twin to update a calculation where perhaps you've got a chain of entities and a result of a change down here in the hierarchy or the graph relationship needs to end up with a change going to the top. Now, the way we have to handle that today is through this external compute, external event processing. We are looking at a better internal event handling mechanism as well between entities in the graph, but today it's based on this external compute. And it can be any other compute resource, by the way, not just Azure Functions, but in all the examples we show, it is actually always an Azure function. Okay, so one of the examples that there is a GitHub repo that you can work through if you're interested in this stuff, and I've got the link to that. Is when it comes to showing near real-time data changes. SignalR is obviously a great way to do that, implementing sort of a WebSocket mechanism between the digital twin and the client or the web app. It could be a mobile phone, it could be a mixed reality app, it could be a web app, whatever it is. So you can actually see these values changing against the digital twin itself. And during the Hololens demo, which, by the way, is not a full end-to-end with the digital twin stuff I'm going to show you. It's a little bit smoke and mirrors, but hopefully really light up for you what you can do with this stuff. So if you sort of use your imagination, say, yeah, there's a SignalR app at the back of this, and it's going to be updating some values. But I'll point that out at the time when we get to it. So I mentioned earlier that Azure Digital Twin only stores in its property for each twin the last known value, so it's not a historical data store. And the strategy by the product group is not to try and bloat digital twin with a huge amount of historical data. Instead, the route we're going is to encourage people to, say, push to either time series insights or Azure Data Explorer. The good news on Azure Data Explorer and time series insights is they're now coming under the same team. You may have felt for a while, if you've looked at this stuff, that ADX and TSI seem to be kind of doing similar things, but they sort of seem to come from a different place, and there was sort of internal structure reason for that. So one of the great things about them coming together is how close that integration is going to be, and the work that's being done to improve this, to make sure that when you have your historical data in one place but your current values in the digital twin itself, that there's going to be a better experience there that's coming. So again, a pretty standard pattern: Azure Event Grid into Azure Functions, push that into another event hub, which can then be used directly to ingest as an event source into time series insights. Not everything has to pass through digital twin. It might not make sense. You might not want to pay for the cost of having every single piece of data going through. Again, think about it as a path in a lambda architecture. You might not always want to push everything through, just what's relevant that you're going to get additional business value from. And the extra piece here is about this client app, where we're starting to build the time series models, the hierarchies that you see in time series insights, now to be informed from the Azure Digital Twin. So again, this is one of those times where you kind of have to do the same piece of work in a number of places. You've perhaps got some asset management databases with some kind of structure. You're reproducing that in digital twin. You now need to reproduce a model in time series insights. So when you are clicking down into that hierarchy, whatever use case the user is executing, that model and hierarchy makes sense for them, and that is something that this client app is doing in this case. Okay, so think about the model view controller pattern's been around for a long time. I'm sure you're all familiar with it, and digital twin is a great example of a model in this case. And we've talked about how we can get data updates from there to build that view for a particular user, and they might then make changes that get pushed back into the twin. So just another example of where digital twin would sit in an architecture. So when we start to talk about geometry, this is where we really start to light up digital twins, and it starts to get a bit more exciting. And a number of partners that we're working with are doing exactly this, where there is a link, just some kind of ID link between the digital twin with some kind of property, could be geospatial, could be maybe even a spatial anchor, an Azure spatial anchor, or some model ID. And then in the 3D representation of that it could be, say, Unity or Unreal, or then pushed into mixed reality. This is really where you start to light this stuff up. We recently acquired, as Microsoft, a company called Marsden Group, who were very famous for doing the work with Unilever, where they were modeling using digital twin the production lines. I think it was in Brazil, making Dove soap. And what Marsden Group do as part of their engagement was to 3D scan each part of the production line, so that then you could actually view that with that data overlaid over the top. And this is always something that gets people very, very excited, because suddenly you've got this excellent training tool, you've got an excellent visualization tool, and I'm going to show you what I mean by that with the HoloLens stuff. So I mentioned spatial anchors already. This is how we really, really start to tie our virtual representation with a view that end users can really get hold of and really light up what this data means to them when they look at a piece of machinery. You get this telemetry coming in. They can go anywhere on the factory floor. Fantastic for accelerating new joiners in a lot of these environments. There's a lot of information locked up in people's heads. Excellent way for training. And again, I'm going to show you some of that stuff. I did a hack with one of our partners with Azure Indoor Maps, and this is really interesting because yet again, it's yet another place where you need to build some kind of representation of your physical world. There is something called the Azure Maps Creator, where you can import DWG files from AutoCAD, and with some additional metadata, push that up into Azure Maps. So you've now got a representation of a building, but with specific elements that you've added in. And then you can start to push information from the digital twin onto Azure Maps to highlight particular areas, for example, with a room status color, etc. So this is another really exciting element where as you start to pull all of these things together, it really is becoming incredibly powerful. Okay, so sort of machine learning. I'm not going to drain this slide. The only thing I want to say about machine learning right now is that I've yet to come across a really good example where someone is using the additional twin specific structure as part of their feature engineering in a machine learning model. As many of you will know, creating a machine learning model in say the classic machine learning technique, if you're doing say regression or classification, decision trees, etc., it is about taking the data that you've got, but then engineering features from that in terms of say how rapidly a value is rising and falling over time compared to others, etc., etc. And you don't need digital twins to do that, right? We've done machine learning perfectly well without digital twins. But I'm yet to see a really good example of where people are engineering features based on the actual twin structure itself. If anyone's come across that, I'd be really interested to know about that. I'm sure someone's done it, and I'm sure that it will happen, or it will happen soon. I just haven't come across it yet. Right, so this is the example I was talking about. How are we doing for time? Probably 10 to. Right, I'm going to speed up a little bit now. I'm not going to dwell on this too much. I would encourage you to have a look at that demo. What I'm going to do I've got a few more slides here, but I'm going to take a quick break because I actually want to show you some of the stuff. And what I'm going to do is pull up here something called the ADT Explorer. So this is not part of the actual service ADT. This is a GitHub project that you can spin up and run either locally or run in the cloud. This is actually running in the cloud. So this is where we can start to visualize the stuff that's in digital twin. So I mentioned building the twin from the models. And to do that, you would upload a model, and here are all the JSON files of the different entities that comprise this ontologies. So I can just upload all of those in one go, and this is what I get here. To create the graph itself, I can actually import from a spreadsheet. So I could import that spreadsheet there, and that spreadsheet looks a little bit like this. So you can see here I've got model IDs that say, right, I've got a supplier, I'm going to give it a unique ID, and then I can define some relationship. So this, you probably create this from some kind of existing asset management system, as I mentioned before. You're not going to do this by hand for sure. So we've instantiated now instances of our models. So again, think of this as an object orientation class, and then these instantiations as an actual instantiation of that class. Now what I'm going to do here, select star from digital twins, and let's see if my zoom it is working. It is. Good old Mark Krasinovich. There we go. So select star from digital twins, and I'm just going to run that query, and you can see it's thinking about that, and then it's going to build all those relationships, and I can actually do this in a different layout if I want, depending on sort of what I'm trying to see. You'd be actually amazed if you've got a lot of data and you view it in these different ways. Even by looking at it, it can tell you a lot. The number of connections there are between different groups of nodes. I once did a project a few years ago with a government body. We used a plugin called Node Excel to visualize some quite complex relationship stuff, and it was incredible the insights that you could just get just from looking at the graph. So this is how we this is one of our common dev tools that we use with ADT. I was going to show you one of the import stuff as well, but instead of doing that, I think what I'm going to do now, I'm going to go straight to the HoloLens bit to give us plenty of time if we want to have a chat about this stuff. Actually, it was a bit tricky when I try and put this over my headphones, so I've just got to spin this up, and I'm going to hopefully, if this comes on, it's coming on now. Just give me a couple of seconds. And what I will do, so think about what we've talked about so far, where so we're modeling a fairly complex environment, and now we've got data coming in from, say, some of the machines in that environment, and we want to pass that through to an end user, say a worker in a plant who is needing to perform some kind of maintenance or doing some troubleshooting, whatever that may be. And let's just see, this is just booting up now, so we should be there. So I'm going to do the live stream. So hopefully, Phil, could you just confirm you can see that okay?
Yeah, okay.
Okay, beautiful. So I'll try not to stare too much at my monitor because you'll get sort of this crazy visual feedback that will make you nuts. Right, what I'm going to do, I'm going to go into the lounge. Hopefully you can still see me. And the reason for that is a big room. And I'm going to tap on one of these apps here, and I go to the Viva Flow demo. It's going to take a few seconds to load up. And again,
you're breaking up a bit, Rich.
It's just probably the Bluetooth. Is that better?
Yeah, that's a bit better.
That's a bit better. Okay. Hopefully you can still see this. So, so imagine the scenario here where we've built a solution. We've got our IoT sensors on machines in a quite complex plant. we've got that telemetry coming up. We've built the environment through the models. Now, I'm going to get narration here, but I don't think you're going to see this. Okay, so this is a great example of imagine now I'm a worker in a plant. I need to be heads up, hands free, because I've probably got tool. What I'm going to do, I'm just going to put the model.
We're losing you again a bit, Rich. I think
okay. Is that better now?
It is, yeah.
Okay, what I'll try and sort of stay in here a bit if I can. Let me just see. Okay, so let's go into 3D here. And now you can see, I can see the plant itself. I'll try and stay closer to the edge of the door. But what I'll now do as well, I'll skip this bit. So that's going to blow up. And you can now see as I'm looking around, there's the plant. Now, what I'm going to do is go to full scale. And then you can see. Now, if you can see, as I'm looking at these pieces of equipment, this model ID in 3D to something in the digital twin. Now, as I start to get information from these pieces of equipment, I can start to look at them and say, and just imagine now that I've got that signal or that near real time information popping up that's going to give me that information that I need. Now I'm going to pull in
we can't hear you, Rich. I don't know if you're talking or not.
Yeah. I'm start looking here now.
Yeah, you're breaking up a bit again.
Oh, okay, no worries. That's a shame. I thought my Bluetooth would work a bit better. But let me just stand back there. So now what I'm going to do, I'm going to click on the full scale piece. Bear with me. Hopefully that's working now. Can you still hear me okay?
Yeah, you're slightly roboty, but you're okay.
Nothing new about that, Nick. Right, okay. So I'm going to try this one more time because that's sort of blocked out a little bit there. Yeah, that's blowing up. Again, I'm a person walking around here. You can see how fantastic this is just for zooming in on any piece of equipment. I can get all the latest sensor information coming up, might tell me service records, service information, etc. Everything that's been stored in the twin. And I've seen examples recently with the work with the Marsden Group, where this is exactly what they're doing. They're building these 3D models, and let me just turn that off now. So they're building those 3D models, and that information is all coming in from the digital twin. So what I'll do, there's just another couple of slides that I wanted to show you. I think we're doing probably just okay for time. I mentioned the ontologies before. So the real estate core is a sort of becoming an industry standard. It's very, very popular, and partners are asking for this. If they're doing smart building projects, they will start with real estate core that defines spaces, rooms, etc. And then there's this new one for smart cities as well, which is, you know, for these really bigger projects. And again, I sort of make the point that it's really the use of these industry standard ontologies and the DTDL that's enabling companies and partners to work together rather than work in silos, which any of you who have ever worked in smart building will know that everyone wants to keep the data to themselves. They don't want to share it. They want to sell the insights, which of course is understandable because that's how you get yourself up the value chain. But it has been holding back progress, really. In sort of standardization. So incredibly powerful part of it, Digital Twins Consortium. a number of companies with these here as the founders, where we're really trying to drive this collaboration and openness. So in terms of time, we're probably just at the end. A couple of examples here. ANSYS, great partner who do a lot of work with complex physics, computational physics, and simulations. They now built a solution on digital twin as well to do sort of what if simulation scenarios. Really interesting stuff. And I'm going to stop there just to see if there's any questions, because I know it's getting quite late now. So let's. I'll stop talking there.
Great, thanks, Rich. Any questions, everyone? Whereas Rich, Alistair's got one. Go ahead, Alistair.
I have to ask. In terms of, this is kind of way out of the sort of stuff I'm doing, but in terms of an introduction or something to learn a little bit more about it?
Yeah, absolutely. Learning path. So Microsoft Learn on the internet. Let me just see if I can just find it for you quickly. It's actually Learn IoT. So if you do, there's a new learning path actually. So if you can see this, and if I search in there, digital twin, there you go, develop with digital twins.
Brilliant.
So let me just quickly paste that into the chat. There you go. So you find a few links out from there. There's another GitHub one as well that I might actually have up here. If I can't find it now, I will send it to you, Alistair. But that's quite a good one. So that model that I showed you with all the factory stuff in, all that is available as well. So you can build the whole end to end, including time series insights. The whole lot. It's a great way to get into it.
Thanks. Rich, just a generic question. What's the level of adoption like with twins? Because my perception is it's gone a bit nuts.
Yeah, I tell you, it's funny you said that, because several months ago, I was going, we are going to get a tsunami of people wanting to know about this, and twins has kept us really busy in the last several months. The adoption and the excitement and the speed at which people have gone with it, I don't think I've seen before with any other service.
And what about you're probably going to think, oh, you're bound to ask this question, but what about mesh? Because obviously you've just done a good demo using HoloLens, but I would have thought mesh is going to play into this in a big way as we move forward with that.
I think as soon as you on that right hand side, with everything that sort of is coming out in terms of visualization, connection with business systems, mesh is absolutely another one of those that is going to be so relevant, because as soon as you capture all the enabling data in digital twin, mesh then becomes another outlet and perhaps a way to feed data back in as well. So it's just going to start taking off. There are so many things that you can connect together, and again, really want to make this point about different partners being able to work together, because they're literally speaking the same language now. That golden thread of DTDL from IoT device, advertising its capabilities, digital twin, building a model, there's the data, is really lowering that friction, and it's really accelerating the rate at which all of these different partners are able to contribute their particular domain expertise together. It's really quite exciting.